All right, so our next chapter is all about probability. It's an extremely short chapter. There's not much we do with it. The first section in this first set of notes is about experimental and theoretical probability. So a couple important definitions that we need to know. Outcome is the possible result of an event or group of events. An event may have a single outcome or multiple or a group of outcomes. And then a sample space is a set of all possible outcomes. So if you're rolling a dice, the sample space are the numbers on a dice. So 1, 2, 3, 4, 5, and 6. You're picking a card from a deck of cards. It's any of the deck of cards. So you can have like 4 of diamonds or ace of spades or anything like that. So sample space is just all of your possible outcomes. So probability in general is if the outcomes in a sample space are equally likely to occur, the probability of an event, so P of the event, is a numerical value from 0 to 1 that measures the likelihood of an event. So the probability of an event is the number of possible outcomes out of the number of total outcomes. So it's the number of possible over the number total. And probability can be written as a fraction, a ratio, or a percent. So we can have it as like 3/4, 3 to 4, or 75%. So those are 3 options. We're mostly going to stick with fractions because when we get into compound probability, we'll need the fractions so that we can do some math with them. But feel free to write them as a ratio or percent as well. All right, so there are 2 main types of probability to start with. The first is experimental, and this is something you actually do. So it measures the likelihood of an event, that an event occurs based on actual results of an experiment. Okay. So the probability of an event with experimental probability is the number of times the event occurs over the number of times the experiment is performed. So it's the number that it occurs over the number of times the experiment is performed. And that's with experimental probability. You actually do the experiment. So our first couple of examples. So a quality control inspector samples 500 LCD monitors and finds defects in 3 of them. So what is the experimental probability that a monitor selected at random will have a defect? Okay, so there are 500 total samples, so that's our denominator, and 3 of them had defects. So the experimental probability is 3 out of 500. Okay. You can figure out that percent if you want. I'm not going to. Okay. So in B or 2 or whatever you want to think of this as, if the company manufactures 15,240 monitors in a month, how many are likely to have a defect based on the quality inspector's results? All right, so we're actually going to set up a proportion to solve this. So we're going to do 3 over 500 equals, and then since the 15,240 is the total number, it's going to go with the 500 because those are the 2 totals, and we're trying to figure this one out. So remember, to solve a proportion, we cross multiply. So we get 500x equals 45,720, and then we're going to divide that by 500. And you get 91.44, but that 0.44 has to be included. So we get 91.44, which rounds up to 92 monitors. And in this situation, yes, you have to round up because you have to include this 0.44 of a computer. So round it up. 92 monitors are going to have a defect. All right, so theoretical probability describes the probability of an event based on possible outcomes. So in theoretical probability, we don't actually do any of the experiment. We just look at what's possible and come up with a theory of what should happen if we perform the experiment. All right, so in this case, we want to find the probability of rolling numbers that add to 7 when rolling 2 standard number cubes. Okay, so the easiest way to do this is to make kind of a table. So if we're rolling our 2 dice, these are our options. Okay. And then we would add them all together to see how many different combinations get us 7. So 2, 3, 4, 5, 6, 7. And just go through and fill this in. There's kind of a pattern here. All right, so this would be the chart of all of the possible combinations of when you added the 2 dice together. So we're trying to find what they add to 7. So if you look, the 7s are this diagonal right here. So there are 1, 2, 3, 4, 5, 6 of the 7s. So you get 6 different ways to get to 7 when you add them. But now we need the total number of options. So it's 6 by 6. So there are 36 options. So if you simplify that, it is 1/6. So the probability of rolling 2 numbers that add to 7 is 1/6. Then you can make one of these tables with anything. So if it was what is the probability of rolling numbers that their product is 36, you would change this to multiplication and fill in all of them when you multiply. All right. So you just have to pay attention to what it wants you to do with the number cubes. All right, so with probability, there's something called the complement of an event, and it's all of the possible outcomes in the sample space that are not part of the event. So the sum of the probability of an event and the probability of a complement is 1. So you can write it as the probability of A plus the probability of not A equals 1. Or we can rearrange it and do 1 minus the probability of A equals the probability of not A. And if you want, we can even think of a third one, and we can do it as 1 minus the probability of not A equals the probability of A. So it's the complement is the probability of something that is not happening. So we have this example, and we have a jar that contains 10 red marbles, 8 green marbles, 5 blue marbles, and 6 white marbles. So we're going to find the probability that a randomly selected marble is not green. So the first thing we need to do is find our total number of marbles. So we're going to add 10, 8, 5, and 6, and get our total number of marbles, which is 29. Okay. So we know it's out of 29. Now, we don't want a green marble. So how many of the marbles are green is 8, but we want the rest of them that are not. So to get our denominator, we're taking the 29 and we are subtracting the 8 green marbles and get 21. So the probability of selecting a marble that is not green is 21 out of 29. And that's what the complement of an event is. You could have also done what is the probability that a marble selected is not white. So you would do 29 minus 6, get 23, and it would be 23 out of 29. So this is not white. All right, I think that's the last example. Have a good day.